Okay. And then it's just a bunch of pretty pictures showing all the different ratios of consumption. And this is a really interesting chart. This tells us monthly heating load, and there's a cooling load also. But in the monthly heating load, it tells us what pieces of our building design contributes what amount in what month. So it's a very interesting chart. You take a snapshot of this chart and you go change your building shape to whatever it is. You come back and compare this chart with the new chart. You will find out if the walls that did that impact are roofs or windows. So it's a very interesting chart.
This is a generalized data input, though. It's telling you percentage, 19% of glazing.
Yes.
Can you fine tune it to be more precise based on your location, orientation, etc.? And will it then change those variables?
Yep. As simple as it is, you have some leeway of fine tuning it,
right.
Not to the nth extent.
Because that object was in space. It wasn't determined by orientation.
It was.
It was?
It was.
Okay.
And you can define all that information in here. And I will take another separate time to go through this program.
Right, and you can run this so that in your CVs when you have that building actually modeled.
Right.
And it'll give you a more accurate final consumption.
Right.
This is more useful in pre-design.
Pre-design,
right.
Because you're just looking at shape and form.
And orientation.
Orientation, right.
So print, is it capable of just, it had like 20%?
Yeah, you can just say 20% fenestration. The only negative with this thing is it's going to apply that 20% on all four sides.
Right.
But you can define different glass on the south side versus north side, but it is restricted to that.
So could you just do some glasses with no walls on the roof? Break it up a little bit?
Right, and that's where it gets a little complicated. And at that stage, you don't want to be that complicated. You just want to be at this level. And so that's why it's important not to take this number and say, yes, my owner, you're going to have $17,000 as your bill. You cannot say that because it's totally conceptual.
Very wrong.
Right.
It's like you said at first, it's best for determining this design
shape
versus this design.
Correct.
The same criteria.
Right, and you just figure out, okay, this design is consuming 49 kBTUs per square feet per year. Option B is 42. So if the difference between option A and option B is 7 kBTUs per square feet, I cannot tell my owner that that's what I'm going to say. Still, as a design process, I would say it has a savings. It's a better design, so I'm going to go to option B.
If you have both available.
Right. And these are some of the
Many ways to get option B.
right. These are some of the different climate information that you can also find on Climate Consultant. So I'm going to walk you through. Oh, so this is what happens if I say make an energy model out of it. Remember, it used to be just a mass. Look at now. I have windows. I have skylights. So it automatically puts that information based on what you define in that little box, dialog box. So it's
because you decided it was a penitentiary, it added skylights.
Well, I asked it to. I asked it to add 3% of the roof to be skylights because I assume most of the penitentiary was skylights. So you can play with these numbers and see how much of an impact it is. So what I did here was I just went through and I did some of these for the elementary school. I made some changes in the percentage of window, and I added some shade to the windows, and started to see how the EUI number will change if I do all these different things. So if I
49.
right, well, I'm not sure. So if I do a compare, if I select these three and do a compare, the shape is exactly the same, but I'm just dealing with the different construction materials. There was 44, 51, 48. So you can start to see which combination of things would make more sense.
Add more window?
I think so, 30%.
Okay.
So let's say you start with the design and say 20%, right? Then you do some design daylighting analysis and it comes out that I need actually 30% on my classroom. Okay, so now you go to 30%, then you see what kind of a hit you are taking because you added more windows.
But you're supposedly saving that in your lighting energy on the other side.
Right, and that's the other part of the equation.
That's not
But
included.
from an envelope side, I still have to control that additional windows that I added. So I'm just adding more 2 feet shade on that. So if I do that from 51 and bring it down 48. So we should try to use this as a tool to help the design process and also to help the story.
Have we done it yet? Have we applied that to any projects in concept?
No,
But on these,
not on the, yes.
but on these right here, I mean, you kind of scroll over, but isn't the left one different than the right one? What were your different inputs? Just one example. What were your different inputs on those? And what was the
Right.
comparative impact at the bottom line?
This one, my glass was 20% of all the wall
With no shade.
with no shade.
And where does it tell me that? Up higher?
Oh, it'll tell me.
Exterior window ratio.
Yeah, there's the exterior window ratio 0.2, that number.
Right.
And then if I go to the right, 0.3 here.
With 30% more.
Yes, the one on the right now is also shaded or wasn't shaded?
And then the final one.
Final one is also 0.3, but this one is shaded. And the shaded part, it's hard to tell here because it's in that model here.
But he picked the 3 on the left.
Yeah, I picked the 3 on the left
And
here.
the 2 foot shade.
20%, 30%, 30%, 2 feet shade. And this is just an example, and it will really depend on our project and how we start.
Yeah, go to the bottom line on 3.
The 48.
Oh, bottom?
Yeah, go to on those 3 assumptions, what were the differences? Yeah.
Right, and this one was on the 30% window with 2 feet shade, I was 48. And 30% windows with no shade, I was 51. So and then 20% windows with no, I think I may have had
Whoa.
shade, 44. So
Whoa, what happened there?
She had less window.
I had less windows.
Oh, okay. Yeah, I'm sorry, one right direction.
Yep.
Yeah.
Yeah.
You just need to do this while you build a road model, and step back and look at this to same analysis, same model you build.
It's not
Right.
part of architecture 2011, right?
It is now part of Architecture 2011, but what I would suggest is we really need a building mass to do this. So if you already have a wall, actual wall and floor and whatnot, this won't work. So you have to go to a mass level and then use the mass to generate.
But it's different part.
Right. It will be different. Right. Right.
Now, without running the study on the next project, what did I learn from that? If I use less window, and if I shade it, I'm going to have a better
Right.
output. Now, those are the things you remember.
Right.
You don't have to run the program every time.
Correct. Right. And that's where
Have you done a comparison just by chance with 20% window here versus in northern Minnesota?
Different climate.
Yeah, northern Minnesota,
No, we haven't.
reduction of window may not be in your favor. You may want more window to capture
Right.
That's
capture
good.
heat.
We don't
Passive.
We all here don't do that much work in northern Minnesota.
Right.
Maybe
Most of
once in
it.
a while. But just a simple comparison like that is another one of those little intrinsic things that's interesting for you to know.
I mean, it's got to work. You would think it would
Right.
work, right? It would help you there.
Mhm.
Where more.
I mean, that,
But
that
it's also
information or that.
it's also important to understand in a colder climate you don't want to lose a lot of heat through the windows
Right.
too.
But you can give input even in pre-design on the envelope.
Yeah, exactly. And that's where we can
Right.
use this.
So
tool.
this is pretty obviously helpful at
Right.
pre-design when you don't have the whole sandwich or the wall defined. That's
Right.
almost too late for this simple program to be of use, right?
Exactly. So this is to help us solve those big questions first.
So
And
if you want to do 1942, what you need to do is create a model and should have run this analysis.
Right.
Right. But this is
It's too late
theoretically
already.
too late to be
Yeah.
using this simplistic program.
So then, since she's already through, into CDs, she's going to want to run a different kind of analysis. Can it be still through Vasari, through Revit, or?
No,
What my point there would be,
We shouldn't be doing a program of a project in
Just to-
CDs.
Well,
Just
just
to
to find
validate
out
it,
what your
right.
real UI
Right.
is
Well,
that
okay.
you finally
the reason
ended up
you might be
designing.
doing CDs is value engineering.
Right,
Or
that's
see,
true.
this comes back and says, you gotta lose all your shades because we can't afford it.
right. And for that model, for that purpose, I wouldn't trust this program. Because this
It's too
program
simplistic.
is very simplistic, and many of the assumptions, like that 1900 people, you may not have 1900 people, and that could change what the output is. It will skew that. So I wouldn't use this program. You have to use something different. And that's the intrinsic problem with all these programs, because none of them are capable of doing all this throughout the design process.
Design process.
Right. So we have to switch back and forth. Because if one has the, let's say IES has the capability to do all that, you may not have the flexibility to do that in the early analysis stages, which you need to have the flexibility to be able to design this very well. Otherwise, if you're restricted in making all these different shapes and whatnot,
Back to your
Right.
whole diagram on your range versus your target,
Right.
how much energy we are spending to get from that range to be tight. Do one at a time using some of the individual.
Exactly.
My overall.
Right. And next I want to just